You know how we all just sort of feel time, like this constant forward march?
Yeah, absolutely. It feels totally non-negotiable, just one way.
Right, one way. And you kind of assume that's just how reality is. But it's funny because, well, physicists have been scratching their heads about the why for ages.
hmm Because a lot of the basic physics equations, the classical ones anyway, they don't really care which way time goes.
Exactly. Like, think about a simple pendulum swinging.
Yeah.
If you filmed it and played it backwards, it would look perfectly fine, completely normal physics.
But our experience definitely screams one-way street, doesn't it?
Hmm.
There's a clear arrow.
Totally. So that's the backdrop for this deep dive. There is a new theoretical study
Yeah.
just out in Scientific Reports back in January.
Oh, okay.
And it suggests something pretty wild. Maybe there are two arrows of time, at least at the quantum level, in certain kinds of systems.
The two arrows. Okay, that definitely grabs your attention.
Right. So our mission today is basically to unpack this idea, figure out what it means, what the implications might be, without getting lost in like super heavy math. Focus on the cool aha moments.
Sounds good. So where do we start? This tension between physics and perception is key. Often it links back to thermodynamics, right? The whole entropy thing.
Exactly. The second law. Things tend towards disorder. That classic example everyone uses.
Spilled milk.
Spilled milk. It spreads out, gets chaotic, never ever just jumps back into the glass on its own. That's irreversibility. That's the arrow we usually talk about.
And this new study connects to that.
It does. They specifically looked at what are called open quantum systems. So not isolated little boxes, but systems that actually interact with their environment.
Okay, so they're exchanging energy,
Mhm.
information, whatever, with their surrounding.
Precisely. And that interaction, that exchange, causes changes over time. Think about that milk again. It dissipates its organized state into the environment.
Mm-hmm.
So the researchers use this dissipation, this sort of energy loss or increase in entropy within the system, as a kind of stand-in, a proxy for time passing.
Makes sense. Changes happen over time, so tracking those changes, like dissipation,
Yeah.
is like tracking time itself within that system.
Yeah. And their initial thought, the logical expectation, was that the equations describing this dissipation.
Should show just one arrow, reflecting that spilled milk reality we see everywhere. Asymmetry.
Exactly. Unlike the pendulum, which looks fine backwards, the math for the milk spilling shouldn't work if you just reverse time.
But that's not what they found.
That's the kicker. They used slightly modified equations for these open quantum systems, and what popped out spontaneously from the math was two arrows.
Wow. Okay, two arrows emerging from the equations themselves, pointing in opposite directions for a given moment.
That's the idea. It kind of suggests a symmetry we weren't expecting there.
But wait, what about entropy? What about the second law? Doesn't that demand one direction? The direction of increasing disorder?
Okay, this is crucial. The study says entropy is preserved along both arrows.
Both. How does that work?
Think about the milk again. Let's say you're at a point where the milk is partly spilled. If you imagine time going backwards from that point according to this second arrow.
The milk doesn't just magically unspill and go back in the glass.
No. According to their model, disorder would still increase along that backward path too.
Huh. So whichever way time theoretically goes from that point, things get more disordered.
Exactly. They call it twin entropy. Disorder increases forward in time, and it also increases backward in time from that central point.
So the asymmetry we see might not be baked into the lowest quantum level in these open systems. It suggests maybe fundamentally time could have gone either way.
That seems to be the implication of the math, yeah. From any specific moment in these systems, the physics might allow for two equally valid temporal paths forward and backward.
Okay, my head's spinning a bit,
Yeah.
but let's be super clear. This isn't about time travel, right? We're not talking about building a machine.
Absolutely not. Zero connection to time travel or building time machines. The paper is very clear.
Good.
It's a theoretical model showing that from a given state, mathematically, two trajectories are equally possible, one going forward and the other one going backwards from that moment.
But once a path is taken, let's say our forward path,
Then the familiar physics kicks in, entropy increases along that path, reinforcing that direction, giving us the arrow we experience.
got it. So it's more about the fundamental possibilities at a quantum level, not about hopping in a TARDIS.
Definitely. But the implications are still pretty profound, wouldn't you say?
Oh, absolutely. It makes you reconsider the arrow of time in thermodynamics, for sure.
And maybe even cosmology. I mean, there's that speculative idea, isn't there, about two universes?
Right, the idea that maybe the Big Bang spawned two universes, one moving forward in time, one backward. That study doesn't prove that, of course.
Not at all. But it maybe gives a little tiny bit of theoretical flavor
Hmm.
to thinking about time symmetry on a grand scale.
Perhaps. And it definitely feeds back into fundamental questions in quantum mechanics itself.
The researchers themselves apparently find it really interesting to ask what actually picks the direction.
Hmm. Like, what's the mechanism that makes the arrow speed off one way or the other?
Yeah, they used an analogy I like thinking about city roads. You can map out all the possible roads, all the directions traffic could flow.
But you still need to understand what actually determines where the cars go and why there's a rush hour in one direction.
Exactly. What sets the flow? It's still an open question.
So this research really touches on some very deep conceptual stuff about how we understand reality.
It really does. It adds clarity in one sense, showing
Right.
these two arrows in the math, but adds complexity too, right? Makes you question something as basic as time's flow.
Definitely. So just to kind of wrap the core idea up,
Hmm.
we're looking at a theoretical possibility based on this new study.
Of two arrows of time at the quantum level, specifically in these open systems that interact with their environment.
And this idea of twin entropy disorder increasing along both potential paths that really challenges our gut feeling about time just marching forward.
It leaves you with a bit of a puzzle, doesn't it?
Yeah.
If, down at this fundamental quantum level, both directions are potentially okay,
Yeah.
what does that ultimately say about cause and effect? You know, the way we experience it, where causes always seem to come before effects in our big macroscopic world.
Mm. That is a deep question to ponder. It certainly makes you think about the layers of reality.
Definitely food for thought.
Click like and subscribe to the Unlock Your Mind channel.